Hello students, welcome to Abdemi's YouTube platform for class 12 physics. We will consider a typical problem from electricity, capacitive electrical circuits. See the statement of the problem. C in and C dash in are the equivalent capacitance between points A and B in circuit 1 and circuit 2 respectively. C1, C2, etc. are capacitances in farad and K is a real number. Find the value of C dash in by C in. So this is an infinite capacitive ladder network. There are infinite number of circuit elements, and here actually capacitor notation symbol is something like this, but here we have used a white box like this. Okay, so the network looks like this. C1, C2, C3, C4, C5, C6, and it is an infinite network to infinity. Okay, now in circuit 1, these capacitances are all different. C1, C2, C3, C4 all are different. It is the infinite capacitive ladder network. And in circuit 2, the capacitance value of each circuit element, each capacitor is K times that in circuit 1. So here this capacitance is KC1, here it is KC2, here it is KC3, KC4 and something like that. So we have to find out the ratio of C dash in and C in. That is the problem. So first let us consider this circuit. So what is the equivalent capacitance of this circuit that we want to find out? Now what we do? We consider say this part of the circuit. Let us use white. Let us consider this part of the circuit. So it is basically AB. This is C1, this is C2, this is C3, this is C4, this is C5, this is C6. So just consider a finite segment of the circuit which has finite number of elements. Now what is the equivalent capacitance between these two points we want to find out. So take this one. So this is a series combination of C5 and C6 which is actually C5 C6 by C5 plus C6. Because you know series combination of these two, equivalent capacitance is C dash, then 1 by C dash equal to 1 by C5 plus 1 by C6. So it is C5 C6 by C5. In the numerator it is C5 plus C6. Therefore C dash is C5 C6 by C5 plus C6. That we know. That's why I have used this thing. So this is the equivalent capacitance of C5 and C6 which are actually connected in series. Now this series combination is in parallel with C4. So if I consider these 2 points as 1, 2. So 1 by C12 is equal to 1 by C12 is equal to 1 by C4 plus 1 by C5 C6 by C5 plus C6. So it is actually 1 by C4 plus 1 by C5 plus 1 by C6. Okay. Now this C12 is in series with C3. So we have considered what actually, so we have done mistake over there. Sorry. C5 and C6 are in series. Therefore, the equivalent capacitance of C5 and C6 is this much. Now, this equivalent capacitance is in parallel with C4. So, C12 I can write. C12 is actually C4 plus C5 C6 by C5 plus C6. This is equivalent capacitance between 1. Now, this C12 is in series with C3. So, if I consider these 2 points and 3 are 3, 4. So, 1 by C34 can be thought as 1 by C3 plus 1 by C12. Okay, so it is 1 by C3 plus 1 by C12 is C4 plus 1 by C5 plus 1 by C6. Okay, so this is between equivalent C34 is the equivalent capacitance between 3 and 4. And therefore, this C34 and C2 they are in series combination. Therefore, the equivalent capacitance between these 2 points, 5 and 6, if I call these as 5, 6 points, if I call this C5, 6, which is parallel combination of C2 and C34. So it is C2 plus C34. So it is C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Okay, now this C5, 6 and C1 they are in series combination, and therefore the equivalent capacitance between A and B, if I call it CAB, then 1 by CAB is equal to 1 by C1 plus 1 by C56. C56 is this one, so it is C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Okay, so equivalent capacitance between A and B in this circuit is 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Okay, so let me write down this thing. So this is the expression. So I once again write 1 by CAB is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Now, if all the capacitances are replaced by K times C1, K times C2, K times C3, K times C4, K times C5, K times C6, then the equivalent capacitance will look like how much? So 1 by C dash AB will look like 1 by AC1 plus 1 by AC2 plus 1 by 1 by KC3 plus 1 by KC4 plus 1 by KC5 plus 1 by KC6. Okay, so if I look at this expression, if the ladder is infinite actually, then what will happen? The expression of C in will look like this. So since we are only considering up to capacitor 6, so this part will not be there in the expression. If it is an infinite ladder, then 1 by C can be expressed like this. It will be continued fraction like this. Here I have got 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus this part is missing, so 1 by C6. So this is the expression for infinite ladder. The continued fraction will continue like this. Now, what we have done, we have considered only, say for example, we have considered this part. Okay, and another circuit. Now, so for this circuit CAB, 1 by CAB will be given as, that have just seen, 1 by CAB will be given as 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Okay, and if I consider the another circuit C1, KC1, KC2, this is B, then KC3, KC4, KC5, KC6, then the equivalent capacitance between these two will be same as that, only each C will be replaced by KC. So it is 1 by KC1 plus 1 by KC2 plus 1 by KC3 plus 1 by KC4 plus 1 by KC5 plus 1 by KC6. Okay. Now see, if I multiply this expression by 1 by K, then what will happen? Up to this there is no issue. This expression can be readily written. Okay, now just from this expression you write 1 by KCAB is equal to how much? 1 by KC1 plus 1 by KC2 plus K times 1 by C3, 1 by C3 plus 1 by C4 plus 1 by C5 plus 1 by C6. Now K is there, this K I can bring here I can bring here also, and I can bring here. Here it will be 1, but this K I can bring here and here. So 1 by KCAB, you see this is nothing but 1 by C dash AB. Okay. So C dash AB is K times C. And extending the similar logic, you can write here 1 by C in dash. If it is 1 by C in dash will be 1 by KC1 by 1 by plus 1 by KC2 plus 1 by KC3 plus here it will be KC4, KC5, KC6, KC7, KC8 and continue like this. And you can really show in that case that C in dash is actually K times C in. Okay. So here what is happening? Though the capacitance of each circuit element is multiplied by K, but impedance of each circuit element, impedance Z, is proportional to 1 by C. Since the capacitor of each circuit element is multiplied by K, you can say impedance Z dash is proportional to 1 by Kc. So Z dash is K, Z by K. Each impedance is divided by K in that case, and therefore the Z in dash input impedance of the circuit is 1 by K times Z in. But Z dash in for a capacitive circuit equivalent is actually 1 by J omega C in dashed, and Z in is actually 1 by J omega C in. Since Z dash in is 1 by K times Z in, so 1 by J omega C in dashed is 1 by J omega K C in, and therefore C in dashed is K C in. So capacitance, equivalent capacitance between here actually we have used equivalent capacitance if it is C in dashed. Then impedance, input impedance of the circuit will be 1 by J omega C in dash. J is square root of minus 1. Omega is the angular frequency of the circuit. So we have seen that C dash in is actually K times C. Without doing calculation, if we apply a principle that if all impedance of the circuit is K times, then the equivalent impedance of the new circuit will be K times that. Okay. And since actually each impedance component is 1 by K times that of the original circuit, and therefore we could find that C in dash is equal to K times C. Why it is so? You have understood that Z in dash is 1 by J omega C in dash, and Z in equal to 1 by J omega C. Z in dash is actually each circuit element here offers the impedance, and impedance value is 1 by K times this. Therefore, Z in dash is 1 by K times 1 by J omega C. So 1 by J omega C in dash equal to 1 by J omega K C in. Therefore, C in dash equal to K C in. So this is the relation. And we could straightforward also show like this, because from this expression we could show that C dash AB equal to K times C. Okay, so I hope this is clear. So equivalent capacitance is K times equivalent capacitance of this circuit. So I think you have understood the problem. If you have any doubt, please revert back to us. We will try to clarify further. Thank you very much.